Hello friends, I am Professor Rajendra Koranne from my YouTube channel Teach Easy. In this video, I am going to present the MCQs on the topic columns and struts of mechanics of structures. Now, let us start. Question number 1. A long vertical member subjected to an axial compressive load is called as A column, B, a strut, C, a tie member, D, a stanchion. Now definitely this is the basic definition of column, which is a long vertical member. Hence the correct answer of this is A column. Question number 2. Struts are the members of a strut which are subjected to A. Axial tensile load, B. Axial compressive load, C. Torsional loads, and D. Transverse loads. Now the members in a frame or a truss which are inclined one, okay, generally they are known as strut because they are subjected to axial compressive loads. Some of the compression members in a truss can be vertical also. It is not necessary that it must be inclined. Hence the correct answer of this is B, axial compressive loads. Question number 3. The column which fails due to direct stress is called as A. Short column, B. Long column, C. Medium column, and D. Slender column. The column which fails due to direct stress is always a short column which is crushed, and such types of columns are used in the laboratory to find out the crushing stress of the material of that column. Hence the correct answer of this is A. Short column. Question number 4. The inclined member carrying compressive load is A. Post, B. Stanchion, C. Strut, and D. Column. In the previous questions, we saw that the member in a truss which can be inclined is a strut, isn't it? Which carries a compressive load. Hence, the correct answer of this question is C. Strut. Question number 5. A built-up column made up of rolled steel sections is called as A. Post, B. Pillar, C. Strut, and D. Stanchions. In steel structures, generally the columns which you see on the railway stations are steel columns made up of angles and bars and flats. Such standard section, which is a very heavy column, is known as stanchion, and the correct answer of this is D. Stanchion. Question number 6. The compression member always buckles in the direction of A. Vertical axis, B. Horizontal axis, C. Minimum cross section, and D. Least radius of gyration. Now, whenever we find out the buckling load of the column, we know that it always buckles in the plane where I is minimum, and as I is minimum, radius of gyration is under root I upon A. So definitely it will be along the axis or in the direction of least radius of gyration. Hence correct answer is D, least radius of gyration. Question number 7. The load at which the vertical compression member just bends laterally is known as A. Critical load, B. Crippling load, C. Buckling load, and D. Any of the above. Now, in this particular question, generally when the column buckles in a lateral direction, it is also known as buckling, it is also known as crippling, it is also known as critical. Hence, the correct answer of this question is D. Any of the above. Question number 8. The buckling or crippling load of a column is determined using A. Euler's formula, B. Rankine's formula, C. A or B, and D. None of the above. In the last question only we saw that it is known as buckling or crippling or critical load, like that. Generally, when we are using Euler's formula, we call it as buckling load. When we are using Rankine's formula, we call it as crippling load. The meaning of both are same. Hence, for this particular question, the answer is C, A or B. We can use both the formula to find out the buckling and crippling load. Question number 9. The ratio of the effective length of the column to its minimum radius of gyration is known as A. Buckling factor, B. Slenderness ratio, C. Crippling factor, D. None of this. This is the definition of slenderness ratio, and the correct answer is B. Slenderness ratio. Question number 10. A vertical column of size 100 mm by 100 mm is 5 meter long. Its slenderness ratio will be A. 117.2, B. 17.3, C. 173.2 and D. 137.2. Now this is a very small problem in which you will have to calculate the slenderness ratio, and for calculating slenderness ratio, effective length is given. A radius of gyration you will have to find out. For radius of gyration you will have to find out I and A, and under root I by A will be radius of gyration. Okay, as this is a square column, I will be 100 raised to 4 upon 12 and area will be 100 into 100. So if you calculate I, then A, then I by A under root of it, it will be radius of gyration, and the slenderness ratio will be effective length upon radius of gyration. If you calculate all these things, you will come to know that correct answer is 173.2. Hence, the correct option of this is C, 173.2. Such types of problems are generally asked in the competitive exam, in which you have to calculate on the rough pages given in the examination and you have to pick up the correct answer. Question number 11. For a column of effective length 4 meter, the radius of gyration 40 mm, its slenderness ratio will be. This is again a small problem in which effective length is given, radius of gyration is also given. So you have to just take the division. Effective length is 4 meter, that is 4000. 4000 upon 40 will be 100. Hence the correct answer is C, 100. Slenderness ratio has no unit. Question number 12. Euler's formula is useful for A. short column, B. long column, C. both A and B, and D. none of the above. Definitely Euler's formula is useful for long column. Hence the correct answer of this question is B. long column. Question number 13. A mild steel column having slenderness ratio more than 80 is said to be A. short, B. long, C. both A and B, and D. none of the above. We know the limitation of Euler's formula. Euler's formula is applicable for a particular material for which the value of slenderness ratio is greater than a particular value, and for mild steel you know that it is 80. So if slenderness ratio is more than 80, then only we can use it Euler's formula, that is, it is a long column. Hence the correct answer of this question is B, long. Question number 14. For a mild steel column, Euler's formula is valid if its slenderness ratio is A greater than 120, B less than 120, C greater than 80, and D less than 80. In the previous question we saw that minimum value of slenderness ratio is 80. It must be greater than 80. Hence the correct answer of this is C, greater than 80. Question number 15. The effective length of a column fixed at both ends is A 1.5 L, B L, C 2 L, D L by 2. For both ends fixed, effective length is L by 2. Hence the correct answer is D, L by 2. Question number 16. The effective length of a column fixed at one end and free at the other is A 1.5 L, B L, C 2 L, D L by 2. Now if the column is fixed at one end and free at the other, its effective length is 2L. Hence the correct answer is C, 2L. Question number 17. The strongest column is one whose A. One end is fixed, other end is hinged. B. Both ends are hinged or pin jointed. C. One end is fixed, other end is free. And D. Both ends are fixed. Now here you are asked the strongest column. Now you know that the Euler's formula is pi square EI upon LE square. Hence LE is the effective length which is in the denominator. So whenever the value of LE is minimum, as it is in the denominator, value of PE will be maximum, and value of LE, that is effective length, is minimum when its both ends are fixed, and as it is minimum, its strength will be maximum and it will be the strongest column. Hence the correct answer of this question is D, both ends are fixed. Question number 18. The ratio of buckling load of a column fixed at both ends to the column hinged at both ends is. Now, here P is calculated for column fixed at both ends. It is 4 pi square EI upon LE square. And when both ends are hinged, it will be pi square EI upon LE square. So if you take the ratio, it will be 4. Hence the correct answer is B, 4. Here you will have to calculate it so that the answer may not be wrong. So put it and you will get the correct answer. Question number 19. If the side of a column of square cross section is doubled, the Euler's buckling load will be dash 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 the buckling load of a column of original side. A 2 times, B 1/2 times, C 16 times, and D 1/4 times. Now this is also a short problem in which the side of the square column is doubled. And you have to compare, if it is double, what will be its Euler's buckling load, how many times it will be of the buckling load for the previous column. Now the side is double. Now for PE, pi square EI upon LE square, I is in the numerator, and for square I is a raised to 4 by 12. So if the side is double, it will be 2 raised to 4 times, and 2 raised to 4 is 16. Hence the correct answer of this particular question is 16 times. Question number 20. The Rankine's formula holds good for A. Medium column, B. Short column, C. Both short and long columns, and D. Long columns. Now Rankine's formula can be used for both short and long columns, and the correct answer is C. Both short and long columns. Question number 21. The value of Rankine's constant, small a or alpha, for mild steel column is A. 1 by 7500, B. 1 by 1600, C. 1 by 750, 1 by 9000. Okay. So in Rankine's formula we use small a or alpha, and what is the value of that? The correct value of that is 1 upon 7500 for mild steel. Hence the correct answer is A, 1 upon 7500. Question number 22. For a long column, the value of buckling load is dash 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 crushing load. A more than, B equal to, C less than, and D none of the. Now, if the column is long, it will buckle at a load which is much less than the crushing load. Hence the correct answer of this is C, less than. Question number 23. The column of length 5 meter with both ends fixed is considered equivalent to a column of length dash 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 with both ends hinged. A 2 meter, B 2.5 meter, C 10 meter and D 3.54 meter. Now this is again a good question in which a column is given as both ends fixed 5 meter, equivalent to a column of length dash 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 with both ends hinged. Now for both ends be fixed, what is effective length is L by 2, so 2.5 meter, and what is effective length for both ends is L, that is L will be equal to 2.5 meter. Hence the column of length 5 meter with both ends fixed will be equivalent to a column of length 2.5 meter with both ends hinged. Hence the correct answer of this is B, 2.5 meter. Question number 24. If the Euler's buckling load for a column is given by PE is equal to pi square EI upon XL square, then the value of X for a column with one end fixed and other free is A1, B2, C4, D1 half. This is also a short question, very important one. Such type of questions are asked in the competitive exams. Now here what is given? P is pi square EI upon XL square. What is in the numerator? Pi square EI. What is in the denominator? LE square. So instead of LE square it is XL square. Then what end conditions are given in this? One end fixed and other end free. So one end fixed and other end free means it will be 2L. That is effective length. What will be square of 2L? Will be 4L square. If you equate the denominators, XL square will be equal to 4L square. Hence the value of X will be 4. Hence the correct answer of this question is C4. Question number 25. A rectangular column will buckle in the direction A, in which slenderness ratio is larger, B, in which slenderness ratio is smaller, C of B, D of D. Now here we have seen that whenever I is minimum or the axis about which I is minimum, buckling will take place, and if I is minimum, definitely the radius of gyration will be minimum, and as radius of gyration will be minimum, slenderness ratio will be more, larger. Hence the correct answer of this is A, in which slenderness ratio is larger. Question number 26. The direct stress induced in a long column is dash 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 as compared to bending stress. A, more, B, less, C, same, and D, negligible. Now the direct stress which will be induced in a long column will be definitely very less as compared to bending stress, and definitely it will be negligible. Hence the correct answer is D, negligible. Question number 27. A column of length 5 meter and diameter 300 mm is fixed at both ends. If the value of E is 2 into 10 raised to 5 Newton per mm square, the buckling load will be A, 12.55 into 10 raised to 4 kilonewton, B, 12.55 into 10 raised to 5 kilonewton, C, 12.55 into 10 raised to 3 kilonewton, D, 12.55 into 10 raised to 2 kilonewton. Now, in this question, you will find that it is a small problem in which column is given, the length of the column is given, end condition is given, value of E is given. You want to find out buckling load. What is formula for buckling load? Pi square EI upon LE square. Okay, I you will have to calculate for circular column of diameter 300 mm, which will be pi d raised to 4 by 64. Calculate I. For both ends fixed, effective length will be L by 2, that is 2.5 meter. Value of E is given. Put all the values in the formula pi square EI upon LE square. Calculate it. You will come to know that the buckling load will be 12.55 into 10 raised to 4 kilonewton. Hence, the answer is 12.55 into 10 raised to 4 kilonewton. Question number 28. A square column of side 400 mm has a slenderness ratio of 90. If the value of Fc is 320 Newton per mm square and alpha is 1 upon 4800, the crippling load will be A. 19051 Newton, B. 19051 kilonewton, C. 19051 into 10 raised to 3 kilonewton, D. 1.90 into 10 raised to 5 kilonewton. Now this is also a question on Rankine's formula, in which square column is given, which side is given, slenderness ratio is given. Okay, so slenderness ratio is directly given, so Fc is given and alpha is given. What is Rankine's formula? PR is equal to Fc into A upon 1 plus A into bracket slenderness ratio square. So it is directly given. So if you put all the values, you will come to know that value of crippling load will be 19051 kilonewton. Hence the correct answer is B, 19051 kilonewton. Question number 29. If the Euler's buckling load for a long column is given by P is equal to pi square EI upon XL square, then the value of X is minimum when A. Both ends fixed, B. One end fixed, other free, C. Both ends hinged, and D. One end fixed, other hinged. Now such type of question we asked in some previous question it was asked, but there value of X was asked for a particular end condition. Now here it is asked that when value of X will be minimum. Now it is in the denominator, so denominator is equivalent to LE square. So LE square will be minimum. X will be minimum when LE will be minimum, and LE will be minimum when both ends are fixed, that is L by 2. Hence the correct answer of this will be A, both ends fixed. Question number 30. An electric pole is 6 meter high from the ground level. Its effective length will be A. 6 meter, B. 3 meter, C. 12 meter, and D. 4.24 meter. Now here it is nothing but a column which is fixed at the bottom and free at the top. So it is fixed at the bottom and free at the other. Hence the effective length is 2L. Hence 2 into 6 is 12. Hence the correct answer is C, 12 meter. Thank you.